Hello students, welcome back to my channel. In this video, we are going to discuss an example based on Fourier series and in particular, it is based on art and human nature. Okay, we can solve this example by the help of art and human nature. Okay. So, what is the advantage of studying or using or understanding the concept of odd and even in Fourier series? Okay, students, look at in generally you people already aware that the function f of x is said to be even. Okay, we are going to replace x by minus x as to retain f of x. Call it as even. Odd is f of minus x is equal to minus f of x. Okay, so this is if I in particularly we have go for Fourier series in the interval uh, that is minus pi to pi okay, so it has a periodic function of period 2 pi in the interval minus pi to pi. How to calculate even and odd nature for a single is in this manner, or it is in general procedure, but it differs in the interval 0 to 2 pi. In this interval 0 to 2 pi, to say that the given function f of x is even, we are going to replace x by 2 pi minus x and it will become f of x. We say that even, and which is odd, f of 2 pi minus x is equal to minus. Okay, fine. Now we also understand in case of if the function f of x is expressed in terms of two cases, we call it as phi of x and psi of x. So ಈ ತರ ಕೊಟ್ರೆ ನಾವು odd and even nature. So this is minus pi and 0. Okay, this is 0 and pi. ಈ ತರ ಕೊಟ್ರೆ ನಾವು odd and even nature. How to verify that the given function is odd or even? So in this manner, what we are doing is we'll take phi and replace x by minus x. You have to get uh, the value of psi of x. So phi ಅಲ್ಲಿ x ಇದ್ದಲ್ಲಿ minus x ಹಾಕಿದ್ರೆ second function ಬಂತಂದ್ರೆ ನಾವು we call it as a even. Okay. Otherwise, if phi of minus x equal to minus psi of x, we say that the function is odd. Okay. So let me verify for our given example. Okay, verify for the given example. Okay, here what is phi of x? What is phi of x? Fine, phi of x is equal to 1 plus 2x by 5. And what is psi of x is 1 minus 2x by 5. Okay, let me replace in the first one x by minus x. It will become 1 plus 2 times of x by minus x by 5, which is equal to 1. This is minus 2x by 5. 1 minus 2x by is same as psi of x. Phi of minus x equal to psi of x. We say that our function f of x is even. Okay, what is the advantage of finding the given function is odd and even? Okay, now let me come back here. Okay. You know that a Fourier series, right? Fourier series f of x equal to, you know that a naught by 2 plus summation n runs from 1 to infinity a n cos n x plus summation n runs from 1 to infinity b n sin n x. Now, and you know that what is a naught? A naught is equal to 1 by pi. Integral runs from, okay, let me take, this is first minus pi to pi. Let us discuss minus pi to pi because it is, our example is minus pi to pi. First, I will write f of x into dx. Now, students, what we understand by the help of even and odd nature is, okay, for example, if the function f of x is even, okay, what will happen? And you must also remember the one of the important property in the definite integral, that it is minus a to a f of x dx value is, has two values. One is from 0 to a, half of minus a to a into f of x into dx. This is this is when the function is even, 0 when function is odd. ಏನಾಗಿರ್ಬೇಕಂದ್ರೆ the interval should be minus pi to pi ಆಗಿರಬೇಕು. ಅಂದ್ರೆ a value is here pi. The interval should be pi and minus pi and pi, and the function is even, then it will become a what? 2 times. 2 times of 1 by pi. Half of this interval is 0 to pi. Okay, one thing we know. But if the function f of x is odd, what will happen? If function f of x is odd, it means a naught becomes 0. That is the powerful method to use the definition of odd and even nature. Okay. So once you know that the given function is even, then it is not necessary to find out bn. Why? It will become 0. How? How bn becomes 0? Students, we know that bn equal to 1 by pi, integral runs from minus pi to pi. So that is f of x into sine, f of x into sine. Okay. Since we know that sine nx is odd function, okay, f of x is even function, odd into even. Odd function into even function is odd. Therefore, when the function f of x is odd, then it will become 0. But it differs in case of an. An value is, you know that 1 by pi, runs from minus pi to pi, f of x into cos nx. But here f of x is even, cos x is even, okay, even into even is even, then it will become 2 times of 1 by pi minus pi to pi f of x. Sorry, not minus pi to pi, 2 times of 1 by pi into half of minus pi to pi is 0 to pi. This is f of x into cos nx into dx. Okay, so that is the advantage of using even and odd nature. So let me go for further. Okay, since we know that the given function f of x is even, so the function is even. Okay, first I am writing the, okay, if the function is even, directly you can write bn value is 0. Since since f of x is even, then bn is equal to 0. Then, okay, the required Fourier series. What is required Fourier series after Bn is 0 is f of x is equal to a naught by 2 plus summation n runs from 1 to infinity a n cos nx. But here the Fourier coefficients a naught becomes 2 times of 1 by pi. Integral runs from 0 to pi. F of x into dx, and a n is integral runs from a n value is, which is 2 times of 1 by pi 0 to pi f of x into cos nx into dx. Fine. A naught is equal to 2 by pi. Look at student. What is the value of f of x between 0 to pi? Let me go for here. Between 0 to pi, between 0 to pi, its value is 1 minus 2x by pi. Its value is, what is its value? 1 minus 2x by pi. One minute. Okay. 1 minus 2x by pi into dx. Okay. Let me calculate this value. Okay. Fine. Integrate it. This will become 2 by pi. Keep it as it is. So here limits are 0 to pi. Integration of 1 is x. 2 by pi is constant. Integration of x is x square by 2. Between 0 to pi. Okay. Now let me go for cancel this 2 and 2. Okay. Fine. Now which is substitute upper limit and lower limit 2 by pi. Upper limit is pi. Pi minus. This is pi square by 2. Okay. Fine. Upper limit is over minus. Lower limit is pi square by not 2. This is pi square by pi you will get because 2 and 2 will get cancelled. Minus lower limit is substitute 0 minus 0. So this pi and 1 pi get cancelled. So this is 2 by pi. Pi minus pi, that is 0. So the value of a naught is equal to 0. Then we'll go for finding a n. A n is equal to 2 by pi. 2 by pi. F of x value is, okay, just substitute the value 0 to pi. F of x value is, the interval 0 to pi is 1 minus 2x by pi into cos nx into dx. Students, here we are using the Bernoulli's generalized method for integration by parts. So which we have already discussed in the last example. Please go through the first example, then you go for this example because there we have explained beautifully. So that is integration of product of two functions by using Bernoulli's rule is, this is first function, integration of second function, minus differentiation of first function, double integration of second function, and so on. So look at here, this is 2 by pi, keep it as it is. First function is 1 minus 2x by pi. Integration of cos nx is sin nx by n, minus differentiation of 1 is 0. 2 by pi is constant, x is 1. Again, integration of sin nx is minus cos nx divided by, already there is one more n, so it will become 1 by n square. The next differentiation, 2 by pi becomes 0. That's what we are stopping here itself. This is 0 to pi. Fine. 2 by pi, you people already aware, sine function for the upper limit 5, sin pi is 0 and lower limit 0 is also 0. So we are not going to substitute anymore. Okay, now you concentrate only on second term. What is second term? Minus minus plus, again there is minus, I will take minus sign outside. Okay, again this 2 by pi and this 1 by n square is also outside. So what is remaining? Only cos nx. So what you will get? Substitute x is pi, cos n pi minus cos n into 0 is just 0. So this is minus 4 by pi into pi is pi square n square, and you know that cos n pi value is minus 1 whole raised to n minus cos 0 value is 1. So this is the value of an. Therefore, what is the Fourier series? The Fourier series becomes f of x equal to a naught value is 0, just leave it, okay, plus summation n runs from 1 to infinity. An is minus 4 by pi square n square into minus 1 whole raised to n minus 1 into cos nx. This is the required Fourier series. So we need to deduce. Okay, we need to deduce uh, a required Fourier series by the help of this. That is 1 by 1 square plus 1 by 3 square plus 1 by 9 square, so on, is equal to pi square by 8 by the help of this. So I will rewrite this one again. So f of x is equal to minus summation n runs from 1 to infinity 4 by pi square n square into minus 1 whole raised to n minus 1 into cos nx. So just you can go back and observe. Minus 1 whole raised to n minus 1. Okay, fine. Now, to reduce the series, we need to substitute the value. Before substitution, you must write the value of minus 1 whole raised to n minus 1 value. If I take n is equal to 1, minus 1 whole raised to 1 is minus 1 is minus 2. If I take, this is when n is odd. If I take n is even, this will become 0. Okay. So for that, so here minus summation, here n takes the value 1, 3, 5, so on. Only odd values. So you can write 4 by pi square n square as it is. This value becomes minus 2 into cos nx. Okay, fine. Now f of x is equal to minus minus plus. This will become 8 by pi square. I will take outside and n runs from 1, 3, 5, so on as it is. Okay, you will get cos nx by n square. Now let us substitute the value of x. Substitute x equal to 0 because we have an interval from minus pi to 0 and 0 to pi. Okay, the first value is 1 plus 2x by pi, 1 minus 2x by pi. Okay, so if I substitute, okay, there is a less than symbol there. Okay, you can first one you have less than or equal to, and this is less than symbol, and x equal to 0. Okay. So students, the symbol, it's depending on the symbol, just to concentrate. If it is in this form, minus pi less than x less than or equal to 0, you need to take first one. If the second also involves 0 less than or equal to x less than or equal to pi, you can take any one of these two. But if it is only less than, if it is less than or equal to, you take first one. If a second one is less than or equal to, if first one is less than, you can take second one. So in both the cases, so it will exist. So first write this is f of 0, 8 by pi square, substitute n value, and observe. N is 1, you will get cos x by 1 square, cos 3x by 3 square, plus cos 5x by 5 square, plus so on. Okay, fine. Now, f of 0 means I told it. So in x equal to 0 means you can take. So you will get both the case, it is 1 is equal to 8 by pi square into 5. So what we have taken student here? Here we have taken n is equal to 1. Okay, first we need to expand, then you can substitute here. Okay, of course, now you can substitute x is equal to 0 here. Okay. Cos 0 is, okay, you can write once again, cos 0 by 1 square plus cos 3x by 3 square plus cos, not 3x, okay, cos 0x. So, when x is 0 means again cos 0 itself by 3 square plus again cos 0 by 5 square plus so on. Okay. Look at student, first you can expand it and substitute. But what we have done is that here we have substituted and we have expanded. But you people need to do is first expand it and substitute the value of x equal to 0. So cross multiply it, you will get pi square by 8 is equal to cos 0 is 1, you will get 1 by 1 square, 1 by 3 square, plus 1 by 5 square, plus so on. So this is the required Fourier series by the help of given function. Thank you so much for watching. Students, if you have any doubts regarding this example, please compulsory mention your comment and uh, like the video if you really understand the comment.